Hello, everyone. This is the Honey Nut Cheerios team presentation. My name is Evan.
And my name is Sean.
My name is Atanj.
And my name is Ro.
And my name is Jaden.
So when thinking of our project idea, we had a large amount of them. However, we had to settle on one final one. So here's what we knew. Autonomous race cars are cool. Roller coasters are cool. Car jumps are cool. And by this point, it is obvious.
So that was the final project idea we chose. Autonomously trying to make our car go in a roller coaster type course.
During class, we used the race car in a simulation made in Unity. As you can see with these images, all levels are made in Unity and the structures can be made in Unity or with 3D modeling software.
We faced multiple problems when originally designing our course. The first one was actually trying to create the ramp and loop.
We tried to make the ramp and loop in 3 different ways and wanted to continue to choose the best one. First, we tried using the simulator to create a ramp and loop.
However, it wasn't as easy as it seemed. Since Unity isn't a modeling software, creating the loop required creative solutions and was more difficult than we thought. We tried to use pre-made ramps and arrange them in a way we needed, but when the pre-made ramps weren't what we wanted, we tried aligning a bunch of rectangular objects to make a ramp. That didn't work either.
We tried using SolidWorks to create the ramp. However, we encountered challenges there too, such as trying to make the ramp smooth so the car could actually go on it. Also, we had to make sure the ramp is on the correct scale when we put it in the simulation.
And finally, we tried to use Blender to make the loop. We encountered the same problems we did when using SolidWorks. Furthermore, importing it into the simulation turned out to be harder than we expected.
Another problem we faced was trying to put a colored line on the track for our car to follow. We tried to tackle this problem in different ways also.
In Unity, the colored lines cannot be put on straight onto curved surfaces, so we had to break up the line into tiny segments and put it onto the loop.
In SolidWorks, we had to do something similar. We had to use small-sized rectangles of the same color and put them in a line pattern.
In Blender, we tried to put a stripe pattern through the middle of the loop that could be used as a line for the car to detect it.
Eventually, we found a final solution. We decided we would use a mix of all 3 pieces of software. This was because each piece of software had its own advantages.
SolidWorks allowed easy development of the ramp because of its functions. Blender allowed easy development of the loop because it mostly works in polygons. And Unity, because of its easy segmentation of the lines, was used for the lines.
So this is our final race car course. We have a steep ramp leading into a loop. At the end of the loop, we have a ramp which our car jumps off of. Finally, we have a green cone to signify the track is over.
Here's a snippet of our code. We first isolated the red line from the front camera, color camera, and to find the center of it. Depending on the value of the center of the red line in relation to the center of the car, we adjusted the front wheels for the red line to be in the center.
We also have to adjust the speed depending on where the car is on the track. For example, if it goes down the ramp too fast, it might fly off. We have an update speed function for this. Finally, if we see a large green cone in the camera, we will stop the car.
And you might be wondering how successful our code is, so we've prepared a demonstration of our car doing the course.
So what would we do if we had more time? We will make the whole course bigger. That means more speed, steeper ramps, and larger loops. The bigger, the better. Thank you so much for watching our presentation. If you have any questions, please list them below.